Hey guys, welcome to our second target in Unit 4. We're going to be doing a flipped video lesson here, working with our polynomial operations, specifically addition and subtraction. So we're experts now working with monomials, using our exponent properties to simplify those. But what about terms with polynomials with 2 terms, 3 terms, 4 terms, and further? We're going to learn how to add, how to subtract, and eventually multiply. In this video here, and I hate this, guys. I'm sorry, I don't know why this keeps coming back, but there we go. All right, so in this video lesson here, we're going to focus only on addition and subtraction. We'll do multiplication later together in class. Now, before we can get going actually into our operations, we got to learn some new vocabulary now that we're talking about polynomials with more than one term. First is the term degree. Now, degree is like a measurement of the polynomial. We measure height, we measure weight. When people are running, we'll measure how fast they go, right? We always give a measurement for how large, how small, how big something is, things like that. And degree is kind of the measurement of our polynomial. The way we find a degree is we take the largest sum of the exponents of the variables of a term in the polynomial. Now, I know that's a mouthful, so let's take a look at an example here and actually break it down. So if we have this 5-term polynomial here, what we're going to do is we're going to look at the exponents of the variables in each term and add them up. So the first term we can see 3 plus 2 is 5. In the second term it's 4. Hopefully you didn't get stabbed in the spleen by that ninja there. That's really x to the first, so that's 4. Then we can see 6 and 3 is 9. Now there are no variables in our constant term, so our degree of that term is 0, and then our last one is 5. Now, we don't add the degrees, we look at the largest degree of any of those terms, and that's going to represent the entire polynomial there. So, the degree of this entire polynomial is 9. All right, so that's going to be a word we're going to be using a lot, not only in algebra going forward, but when you get to AAT and you start working with polynomial functions, the degree will be an important word to be aware of and understand there. We also need to be aware of an ordering our terms, and specifically the order we're going to use most often is descending order. This means ordering a polynomial so that the exponents of a specific variable decreases from highest to lowest, hence the term descending, right? This is going to give us a leading term, and the leading term is the first term in our descending order. It's the term which has the highest exponent of that variable. The leading coefficient, surprise, is the coefficient of the leading term. So let's take a look at the polynomial above, and you can see our directions here are to write the polynomial in descending order for x. So we don't really care about y here, we're focusing on x. So we have 5 terms, and we need the largest exponent of x to be first, and the smallest exponent of x to be last. So if we look at this here, you can see we have the term with x to the 6th, then we have the term with x to the 5th, then x to the 3rd, then x to the 1st, and then nothing, no x. Our constant term would come last, and this polynomial would be written in descending order. We will be using this every time we simplify a polynomial expression. All right, so now we can actually dig into addition. The really good news about addition is you actually already know how to do it. We've already learned the skills to add polynomials. We just need to take them and apply them kind of in a little bit new situation. So we can see like terms. That's our big idea we're going to focus on with adding and subtracting polynomials. Now, to refresh our memory, like terms are terms with the same variables which have the same exponents. So it's got to be the exact same variables with the exact same exponents, and then they're like terms. Remember, with like terms, we can actually combine like terms, combine them together into an individual single term. So let's take a look at an example here. So I've got a 5-term polynomial plus a 4-term polynomial. So the first thing I have to do is look for any like terms between either polynomial. We can see that 4x to the 3rd and 6x to the 3rd are like terms. So I'm going to combine those and get 10x to the 3rd. All right? We can see that negative 7y squared and positive 8y squared are like terms. So I'll combine those and get 1y squared, or just y squared. Then we've got 3xy and negative 7xy. Again, I'll combine those, get negative 4xy. Now, when we look at 12x here, we can see there aren't any other like terms for 12x, so I just bring that down as it is 12x. And then finally, we can see that our constants are always like terms because they have no variables, so negative 12 plus 20 will give me 8. All right, it's really that simple. Just look for your like terms, combine your like terms, and make sure we leave our simplified polynomials in descending order. If you notice the way I wrote the terms down here, they were already in descending order, but if I had done them in a different order, I would have to rearrange them so they were descending. All right, so now that we've done an example together, why don't you give these examples on your own a shot? So go ahead, simplify these polynomials using addition. Pause the video and we'll come back in just a little bit and check to see how you did. Ready? Pause. All right, let's see how you did. Well, take a look at those. Pause the video if you need to, and please mark any that you didn't get right so you can ask questions about those in class. Well, now that we've done addition, let's move on to subtraction. All right, now here's the deal. Subtraction can get a little bit tricky when we're dealing with negative terms, right? Whenever we have minus, subtraction, and negatives, we tend to make mistakes. So let's not subtract. We're going to show you a way that you can change subtraction into addition, and it's that using things we already know. First of all, we already know that there's actually a 1 outside of that second set of parentheses there. So this is really minus 1 times our four-term polynomial. Well, if I want to get rid of the subtraction, what I can do is I can take that negative 1 and I can distribute it to each term in that second polynomial. By doing that, I change the sign of each term in the second polynomial, and I change the sign of subtraction to addition. So now we can add these terms just like we did previously and not really have to worry about any difficulties or mistakes we're going to make when we're dealing with subtraction of negatives here. All right, so let's apply that same principle here to these 4 problems. First, we want you to change the subtraction into addition by distributing the negative 1, and then simplify the polynomials through addition. So go ahead and pause the video now. All right, let's see how we did. So take a look here. You can see that the polynomials are exactly the same 4 polynomials that we had when we were adding, but now that we're subtracting, we're going to get different polynomials in our simplified expressions there. So again, please make note of any of these you didn't get right so you can ask about them in class. Well, that brings us to the end. That's adding and subtracting polynomials. So let's come to class, and I know it's crazy, but we want you to raise your hand if anything here was a little bit confusing and actually let us know. All right, we'll see you in class. Peace.